Hello dear friends, this is Sonigra and today in the subject of mechanical drafting we are going to discuss the chapter titled as Projections and Sections of Solids. In projections of solids previously we have discussed about various basic concepts and types of solids. In today's discussion we will cover few objectives which is listed like this. The first objective for today's presentation is to identify position of solids under given conditions, to solve the problems of various solids, and to understand the concept of projections of solid. So we will cover these aspects in today's presentation. In position of solids, we have studied four types of solids, that is prism, pyramid, cylinder and cone. And in these four solids, let me take the first solid, that is cylinder and cone. So for cylinder and cone, only one position in which a solid, this cylinder or cone may be placed with its base on HP is like this. Suppose it is given that the cylinder is resting on its base on HP, it would be like this. Here the cylinder is resting on HP on its circular base. So the top view will represent a circle of diameter of the equal to cylinder, and height of this rectangle as a front view, and height of this rectangle is equal to the height of this cylinder. This is the axis and this is the base on HP. So only one possibility is there whenever it is given in the data that cylinder is resting on its HP. If it is given that the cylinder is resting on VP, or it is given that its circular face is on vertical plane, then both the views would be reversed. Its front view would be a circle and its top view would be a rectangle. In the second, that is cone, this is a cone. So for the cone also only one possibility is there, either it is resting on HP or resting on VP. If it is given that it is resting on HP on its circular base, then its top view is a circle and front view is a triangle like this. Top view is a circle below XY line, front view is a triangle above XY line, and base is on XY line. For top view, this XY line is vertical plane, and for front view, this XY line represents horizontal plane. If it is given that the cone's circular base is on vertical plane, then just we have to reverse these two views. Say this circle will be above XY line, this triangle will be below XY line. So only two positions would be there with this type of solid. Now second, four positions of prism are possible when it is placed with its base on HP. Like this. This is a triangular prism. Two triangles are joined with the slant edges as shown over here. It has three triangular faces, three rectangular faces and two triangular faces. This is upper triangular face and this is lower triangular face. Now four positions are like this. The first position, rectangular face parallel to vertical plane. If it is given that it's one of the rectangular face is parallel to VP, then we have to draw its top view like this, such that this side is parallel to XY line. Then after drawing this side which is parallel to XY line, we have to draw remaining two sides by taking the distance from this point or by taking arc from these two end points of this line segment. Say here line segment AC is drawn. So first it is drawn parallel to XY line and then we can complete the steps. And then by taking projections from these three end points, we can draw its front view which is rectangle, and the height of this rectangle would be equal to the height of this triangular prism. And this is the base on HP. It is drawn over here. Now second position, rectangular face perpendicular to VP. If it is given that its rectangular face is perpendicular to VP, then we have to draw this triangle in this way, such that this one base is perpendicular to XY line. So first we will draw this vertical line, then by drawing arc or by measuring the distance we can complete this triangle, and after that by taking projections from this top view we can draw this front view. So this is the second position. The third possible position, that is rectangular face inclined at certain angle to VP. If it is given that its face is inclined at certain angle, say 60 degree or 30 degree or at an phi angle. So how to draw the top view of such kind of solid? So for that, first we will draw a line at an angle of phi with xy line like this, any line at an angle of phi degree. After that, on this line put 2 points at a distance of side length of this triangular prism. After locating these 2 points on this line A and C over here, we can complete this triangle by drawing arcs or taking projections, and by taking projections from top view to front view we can draw its front view. So in this case we have to think about the visibility of these edges. If it is tilted like this edge would be visible, so that to be represented by full line like this. This full line represents this edge B. Similarly, we can locate its midpoint by joining the midpoint of adjacent side to the opposite corner, and we can find out its midpoint or axis, and that axis can be drawn or shown by this chain line. Then fourth position, rectangular faces are equally inclined to vertical plane. If it is given like this, then we have to draw its top view in such a way that these two sides makes equal angle with xy line. This internal angle is 60 degree, so this external angle also would be 60 degree. So these two lines makes an angle of 60 degree with xy line, and all lines are of equal length. So join these lines, and by taking projection from this top view we can draw this front view as well. And here this edge would not be visible, so here we have to draw a dotted line, but again here the axis would be there, and axis would also pass through this point. So here two lines would be there, one line which represents the axis and another line which represents the dotted line. So we have to draw the axis first and then after dotted line. So these are the possible 4 positions for triangular prism. Next, 4 positions of the triangular pyramid placed with its base on HP. If it is a triangular pyramid, then also 4 positions would be possible. In triangular pyramid, one difference is there, that is its front view would be triangular in shape. So this is a triangular pyramid. The first possible position, that is base edge parallel to vertical plane. If it is given that the base edge is parallel to VP, then we have to draw its top view such that this side is parallel to XY line. Say ABC is the triangle, so AC is parallel to XY line. Then find out its apex point. So for that, find out midpoint of BC, it is somewhere here, and join that midpoint with point A. So this is one line. Similarly, find out midpoint of AC and join it with the B. So intersection of these two lines will show the axis of this solid, and from this axis draw a vertical line which represents the axis of this solid, and on this axis mark a point at a distance of this height from XY line and complete this triangle. And here this base is on HP, and this is the axis and this point is called as the apex point of this solid. Second possible position, that is base edge perpendicular to vertical plane, similar to this triangular prism. In triangular pyramid also it is possible that this edge is perpendicular to XY line. So first we have to draw this line at an angle of 90 degree to XY line, and length would be equal to the side length of the base, and complete this triangle, and from this triangle take projections similar to the first case, and we can draw its front view as well. The third position, base edge inclined at phi angle to vertical plane. So here again this angle is given, that is phi, which may with XY line. So draw a line at an angle of phi with XY line and complete this triangle, and from these 3 points, end points, take projections and draw its front view. Then fourth case, two sides are equally inclined to VP, or equally the base edge is equally inclined to vertical plane. So here also we have to draw a top view in such a way that two sides makes equal angle with XY line, and that angle would be 60 degree as it is an equilateral triangle. So by drawing this triangle, we can project the endpoints ABC to the front view, and we can draw its front view as well. And here also two lines would be there, the dotted line and central line both will be overlapped in this portion. Now position of solids, the first case, axis perpendicular to HP and hence parallel to both VP and profile plane. If the data is given like this, the axis is perpendicular to HP and base parallel to both vertical plane and profile plane. So this is the case, as this is a square pyramid, and in square pyramid the axis is perpendicular to HP and parallel to vertical plane. So how to draw this case? So for that, draw XY line, and below XY line draw a square ABCD, join the endpoints AC and BD that represent the edges, and by taking projections from AB, C and D to XY line, we can find out position of point A dash, B dash, C dash and D dash, and draw axis from apex point O, mark apex point O dash at a distance equal to height of this solid, and join there though and complete this triangle, and that is the front view. So this is case number 1, in which the axis is perpendicular to HP and parallel to vertical plane and profile plane. This is a simple case. So whenever it is given that the axis makes a certain angle with HP, first we have to assume that it is perpendicular to HP, and we have to draw this first step. Now second case, case number 2, axis perpendicular to VP and hence parallel to both HP and VP. If it is given like this, this would be the case. Here this green color shows the vertical plane, this is HP, and this hexagonal prism is there. This is hexagonal prism which axis is perpendicular to VP. So to draw the projection of this solid, draw XY line, draw hexagon above XY line, name the endpoints A dash, B dash, C dash and D dash, E dash and F dash, and respectively 1 dash to 6 dash as a bottom edge. Two edges would be there, upper hexagonal face and lower hexagonal face. By taking projection, locate the line at a given height. So height of this prism is given. According to that height, mark a points over here, vertical line from A dash and 1 dash, B dash and 2 dash, and so on like this. So 1, 2, 3, 4, 5, 6 would be on XY line, and A, B, C, D, E, F would be at a height of, at a distance of H. And this is the top view of this hexagonal prism. So this is the second case in which the axis is perpendicular to VP and hence parallel to HP and profile plane. So whenever it is given that the axis is perpendicular to VP or make some angle with VP, we assume this as a first step. This would be the first step in such kind of problems. Now third case, the axis perpendicular to profile plane and hence parallel to both HP and VP. Case number 3, it would be like this. See, it's a second case. In the first case, we have taken that axis is perpendicular to HP. In the second case, axis perpendicular to vertical plane. Now third case, axis perpendicular to profile plane. So how to draw that? This would be the case. In this case, the axis is perpendicular to profile plane. So first draw XY line and draw profile plane, a triangle in the side view. So first we have to draw side view in this kind of cases and take projections. This shows the length of this solid or height of the solid if it is in a standing position. The axis of this solid can be drawn like this. The bottom edge and upper edge can be located like this, which would be the solid lines as it's visible. Name the endpoints A dash, B dash, C dash and 1 dash, 2 dash and 3 dash, and you can take projections like this, or you can draw meter line which is at an angle of 45 degree with XY line. Here directly all the points are transferred by drawing line at an angle of 45 degree, and we can draw its top view like this. You can also draw the arcs. Name the endpoints: 1 days, 2 days, 3 days, 1, 2, 3 and ABC, and this is the top view. So for this case, if you look from the side, it would appear as a triangle. Look from the top, it would appear as a rectangle as shown over here, and look from the front, a rectangle as shown over here in the front view. So this is the case number 3. Similarly, if it is given that the axis makes certain angle with profile plane, in that case also, first we have to assume that the axis is perpendicular to profile plane and draw the first step as shown over here. The solid may be any. Here triangular prism is there. It may be hexagonal prism, square prism, pentagonal prism, or any polygon combination. The steps would remain the same. Now first example, the data is given like this. A regular hexagonal prism of 60 mm sides and axis 160 mm long is resting on HP on one of its corners on the base. The axis makes an angle of 30 degree with HP, and plane of the axis makes an angle of 45 degree with vertical plane. Draw its projections. So here regular hexagonal prism is there. Dimensions are given to us, and it is resting on HP on its corners of the base. So let me think about the solution of this problem. The given data is like this. We can write all this data in short form like this: hexagonal prism 60 by 160 resting on HP, and axis 32 HP, and top view 45 degree to VP. This is the short and sweet data for given problem. So first we have to draw XY line which represents intersection of HP and VP. Draw the axis of the solid, and as hexagonal prism is given, so draw a hexagon below XY line with side length is equal to 60 mm. Name the endpoints A, B, C, D, E and